Hey guys, Mr. Smith here, shooting a video on graphing periodic functions for my 3M class and my 3U class. We're both doing the same content today. And we've been learning about periodic functions. So we learned what makes a function periodic and looked at its properties like amplitude, period, axis, and then we've seen what kind of equations produce these periodic functions. So like the sine function, the cosine function, and we even looked at transformations of those periodic functions. Today, we're going to be graphing periodic functions that might involve several different transformations. Let's get started. So I kind of have an algorithm that we're going to apply to graph a periodic function. And for each one of these, we'll kind of go through the algorithm. And then, if you're watching from home, you'll be able to pause, try a sketch, and then check your answer afterwards, or kind of like pause, unpause, pause, unpause, kind of whatever you'd like. All right, so let's walk through the algorithm with this first example here. All right, so our first function, f of x equals 2 times the sine of x minus 30 degrees minus 3. So what we learned in our last lesson is that we can actually pick off a lot of the properties of this periodic function right from the equation. So for example, I know that the axis will be y equals minus 3 because of the minus 3 on the end. I know the phase shift will be right 30 degrees because it's x minus 30 degrees on the inside of sine. I know that my amplitude will be 2 because I have the 2 out front. And because nothing is multiplying my x, I know that this function will have a regular period of 360 degrees. So how does that help us sketch this sine function? So I have the basic sine function sketched here as a dashed line. And here are my suggestions. Now, this isn't the only way to graph these. I just have found that this algorithm helps a lot of students graph these kind of functions in a reliable and consistent way. So here we go. So my suggestion would be to, once you find the axis, to graph that with a dashed line. So I'm just going to put a horizontal dashed line at minus 3. That's the axis of my curve. Now, an optional thing you can do is you can actually just plot where like the highest values of your function will be and the lowest values. So since our amplitude is 2, we're going to go 2 above that, the axis, and we're going to go 2 below. And we know that our periodic function, our sine function here, will kind of be bound between these two dashed lines. I'm using 2 different colors. You can use different colored pens, or you can just use like different dashes of lines, like solid line, dash line, like whatever you need to do. All right. Now the next thing, so now we kind of know where our sine function is bounded in between, but like where do we start? How do we start graphing the sine function? I refer to this as a starting point of my sine function. That's not really a technical term. It's just something I use in the classroom. Normally, the sine function starts at 0, 0. But in our case, we've moved the graph down 3 because the axis is down at y equals minus 3. And we've also moved right 30 because of the phase shift. So our new starting point, instead of being 0, 0, we're going to go down 3 and right 2, down 3 and right 30 degrees, which would put us right here. And I'm just going to label an SP. That's where my sine function is going to start. From there, and this is familiar, should be familiar to you guys from like graphing the vertex of a quadratic function, right? When you see x minus 30, you go right 30. When you see a minus 3 in the end, you go down. So how do we sketch the rest of this? Well, now we're going to use the period. So if we know our sine function has a point there, if the period is 360 degrees, well, then it's also going to have another point 360 degrees down the road. And on at least on my grids that I use, every tick horizontally is 30 degrees. So every 3 ticks is 90. That means every 12 ticks is 360. So if we go 360 over, that will get us to 390 degrees just off the graph here. One full cycle up and down and back up again will be between these 2 points. Halfway, I'm going to be coming back down to my axis. So 6 squares over, I'll put a dot on the axis as well. I know my sine function will go up and come down and hit that, and then go down and come back up. And then the one more piece of detail we should add is the maximums and the minimums. I know that halfway between these two values, I will reach a maximum. And halfway between these two values, I will reach a minimum. And we have a nice, accurate sketch of our sine function, at least one cycle of it. And then what I like you guys to do is I like you guys to fill up your graph with more points. So we'll go back the other way. So in another 3 units, we'll come back to the axis, 6, and then another 6. That's another 180 degrees. And then we know between these two guys, I'll be going down to a minimum, and then back up and up to a maximum. And then it's just drawing those curves you guys should know so well at this point. Up, down, up, down, up, down. But that's how we can fill in all these details. So we have a very nice detailed graph of this transform periodic function. And we're going to use the same steps every time. Draw the axis, find the starting point, and use the period as well as the amplitude to plot more points. So let's try another one using this algorithm. Okay, so in part B, f of x equals minus 2 times the sine of 2x minus 2. Let's just pick off all our properties. That's something that doesn't require a ton of thought. The numbers are right there for us. The axis, y equals minus 2. Note that we're not subtracting anything off the x. So in this case, there's no phase shift. In this question, we are multiplying the x by 2. So we know that means the period is going to be shortened to 360 divided by 2, 180 degrees. And the amplitude is going to be 2. But note that because it's negative, I might just add a little note here. We're going to start by going down, and we'll see what that looks like in a second. So all those properties, we should just be able to read right from the equation at this point. All right, let's use our algorithm for sketching. Step 1, draw the axis at y equals minus 2. Step 2, optional, but I think many of you guys would benefit from drawing in a dashed line where the max and min will occur. Our amplitude is 2. That means we're going to go 2 above, and we'll go 2 below. So our sine function will be kind of bound there. Step 3, where's our starting point? Normally we start at 0, 0. Where does this one start? Well, things have been moved down 2 and not right or left anything because there's no phase shift. So our starting point now, instead of being at 0, 0, will be here at 0, 2. I'll label that with an SP. That's my starting point. Next, the period is 180 degrees. So I know that on my grid here, 90, 180. If I start here in 180 degrees, I must come back to the same point. Same going the other way, 180 degrees this way. And with a sine function, I know that one complete cycle is 180 degrees. That means I'll come back to the axis halfway in between that at 90 and halfway in between these guys here. And now I need to plot my max and mins. And this is where we just need to be careful. Our A value is minus 2, which means the amplitude is 2. But instead of what usually happens with our sine function going up and then back down, we're going to go down to the minimum halfway between these two values on the axis. We're going to go down first and then up like this. And there's one cycle of our periodic function. And we just do the same thing the other way. Up, down, down. All right, and we have another one. So I'm going to do a couple more. So if you're watching at home, this might get I might be sounding a bit repetitive, but that's okay. You can feel free to pause and fast forward. People in the classroom, they're just going to have to live with it. All right, let's graph C using our algorithm. First step, pick off all the properties. And I might encourage you even here, maybe you want to pause the video and try graphing this one yourself, and then unpause when you're ready to check. But here we go. We'll work a bit faster through this one. Axis, y equals minus 1. Phase shift, because we're adding 90, the the phase shift will be left 90 degrees. The period, I can see I'm multiplying x by a number, will be 360 divided by that number, which is 720 degrees in this case. And my amplitude is 3. Next step, draw on my axis. My amplitude is 3, so I'll draw in my highest point and my lowest with a dashed line, 3 below. Next, figure out where our starting point is. So normally we start at 0, 0. Here, we're going down 1 and left 90. Down 1, left 90, that will start us here. And I'll label this SP for my starting point. Okay, next, our period is 720 degrees. So note that our graph only spans actually 720 degrees. So we're going to have just one cycle on our graph here. And I can't exactly go 720 degrees to the right of my starting point. But what I can do is I can go 360 degrees to the right. I know that half of my cycle will be between these 2 points here. And since my A value is positive 3, I'll be going up to a maximum in between there, like this. And then I'll be doing the same thing as we go to the left. So maybe I'll just add in here that our graph will kind of go like that. And then in another kind of 6 squares, we reach our minimum down here. And then it will start to go back up. And that's kind of the best we can do with the period being so big with this one. All right, let's try kind of one more together. Then we'll graph some cosine functions. So again, if you're at home, you can feel free to pause and slow this down as much as you need, or just speed it up at 2 times, whatever you want to do. So let's walk through our algorithm. Read off all these properties. Axis is y equals -2. X plus 60 means we're going to move right 60 degrees. The period, since I'm multiplying x by 3, it's going to be 360 divided by 3. The period will be 120 degrees. And my amplitude is 3. Let's begin our sketch. Draw the axis at -2. Our amplitude is 3, so 3 above gets us to 1. 3 below gets us to -5, something like that. Where are we going to start? Normally at 0, 0. Here we're going down 2 and left 60, down 2, left 60. Gets us here. Label that my starting point. Okay, now the period of this function is 120 degrees. On my grids, that's only 4 squares because every square is 30 degrees. So one full cycle is going to be between these 2 points, an up, a down, and a down all the way. So halfway, I'll come back to the axis. I go up to my maximum, halfway between those, down to my minimum, halfway between those. And then here is one full cycle of that periodic function. Lots of detail, looks really nice. Now, I've got a lot more room in my graph to just continue that pattern. Remember, since it's a periodic function, it's just the exact same graph, just like picking it up and moving it to the left, just like Control-C, Control-V. All right, that's a nice detailed sketch of that periodic function. Here's another exercise where I give you guys some information and we kind of create our own periodic function. This sine function has an amplitude of 0.5, a period of 720, and has a maximum at 0, 1.5. We're going to represent this with a possible sine equation. So I say possible because you can have really any phase shift you want, slide this function left and right as much as you want, and it'll satisfy these properties. So we're going to assume that our function has no phase shift just to keep things simple. So really we have 3 blanks to fill in. Kind of the blank for the A value, the blank for the K value, and the blank for the D value on the end. So let's work with A first. Note the question just tells us what the amplitude is. that means that we know the A value is just 0.5. We get that because we were told the amplitude. So our first blank, 0.5. Let's do K next. So we are told the period is 720 degrees. So normally, to get the period, we do 360 divided by K. Well, here we're told the period is 720 degrees. So the question is 360 degrees divided by what number? Okay, gives you 720. Now, we've maybe done this one enough that you can kind of already see the answer is 0.5. If you're unsure, a simple way to figure that out is just to use cross multiplication, 1 times 360, and then divided by 720. So our K value is equal to 1 times 360 divided by 720, which is 0.5. So our K value is 0.5. And again, maybe you could have just done that with mental math, and that's fine. And then how about our C value? So the question tells us that we have a maximum at 0, 1.5. Remember, 1.5 is like the Y value. So we know the maximum Y value of our function. We also know what the amplitude is. Well, to find out where the axis is, we can just take the maximum value and subtract the amplitude. Right? The highest value minus the amplitude will get us back to the axis. And if we subtract the amplitude again, we get the minimum value. But so we're a max of 1.5. The amplitude is only 0.5. That means our axis is at 1, positive 1. And so if we were to graph this sine function on a blank grid or using Desmos, we would get a function that satisfies all these properties. And you can feel free to check that out if you'd like as well. All right. The last thing I'd like to do in this video is to graph a few cosine functions. Now, most of what we do graphing a cosine function is unchanged because we've seen the cosine function and the sine function are both kind of those wavy periodic functions. They're just kind of like shifts of each other left and right. So most of what we're going to do is not changed, but the thing that will change is kind of where we start, because the sine function starts at 0, 0. But the cosine function, as you can see I have roughed out here, doesn't start at 0, 0. It starts at 0, 1 with a maximum. So let's talk about how we can make a sketch. But as I said, most things in our algorithm don't change. The axis we just read off. Here it's y equals 1. The phase shift, nothing is being subtracted off the x in brackets there, so no phase shift. Nothing is multiplying the x, so the period is just regular 360 degrees, and our amplitude is 2. So keep following the algorithm. Draw on the axis, draw in the highest and lowest values. The amplitude is 2. And note, these are all things that don't require us to use a lot of thought. So, in terms of an assignment or a test, there's a lot you can do right off the bat that will help you get a lot of par marks, even if your graph is wrong. Everybody can do this. All right, so where to start? So you have to be able to recognize whether you're graphing a sine function or a cosine function. So we know that we're graphing a cosine function. Normally, those start at 0, 1. In this case, so at a maximum. In this case, there's no phase shift, but the amplitude is 2. So instead of going 1 above, we're going to have a maximum 2 above, right up here. So we start with the maximum. That's our starting point for our cosine function. So it's a little different. Cosine starts, the starting point is like a maximum at that highest value. Now the rest is the same. We use the period and the amplitude to plot more points. Our period is 360, which means in another 360, we're also going to have a maximum. I can do the same back here. Within those, I'm going to go from a max down to the min, back up to the max. Well, halfway in between, where's the minimum going to be? Well, it's going to be down on my dashed line, down here at 180. And I can do the same thing between these two maximums here. I can also add the detail that halfway between the max and the min, I'll be coming back to the axis, so I can add more detail. Halfway between max and min, halfway between max and min. And we're ready to graph our periodic function. Just kind of connect the dots with a smooth curve. Just like that. All right, so let's draft another one. Again, what you'll need to practice is to kind of figure out where to start your cosine function. Maybe you can pause the video and try setting this one up yourself, but let's walk through our algorithm. Axis y equals 1. Phase shift here is right 90 degrees. Period, nothing is multiplying the x, so 360 degrees. And my amplitude is 3. Let's draw on the axis at y equals 1. Let's draw in our highest and lowest values with a dashed line, 3 above and 3 below. 3 below is minus 2. Okay, so normally cosine starts at a maximum, but this time our amplitude is 3, our maximum is up here at 4, and we've moved everything over 90 degrees. Our maximum will start here at 90. It's been moved right by 90 degrees. This will be our starting point. 360 over from here, I'm kind of off my graph, so I'll go 360 back this way. That gets me back to minus 270. I'll have a maximum there. Halfway in between, 6 squares, I'll have a minimum. And then halfway between my max and min, I'll come back to my axis. So here's one cycle of our cosine function. But we can add some more detail. In 3 squares, we come back down. I just like you guys to fill your graphs up. In 3 squares, we come back down. In another 3 is our minimum. In another 3, we come back up to the axis. All right, and we've graphed another cosine function. I've got one more here, which really ties in every single possible transformation. We have a different axis, a phase shift, the period has changed, the amplitude is not 1, and we've got a negative value here. So if you can really wrap your mind around C, then you're really in good shape. But let's just start with our algorithm. There's a lot we can do that doesn't require any thought. Our axis is 1, y equals 1. Our phase shift is left 90. These things just come right from the equation. Our period, we're multiplying x by 2. So our period will be 360 divided by 2, 180 degrees. And our amplitude will be 4. Amplitude is always a positive value. However, because it's negative, I might add a little note here, just like before. I'll just put starts going down, and we'll talk about what that means in a second. Okay, everybody can pick off those values from the equation. Everybody can draw on the axis, y equals 1. And everybody can draw 4 above that using the amplitude. That gets us to 5. And 4 below that, which gets us to minus 3. Okay, so all those steps should be just kind of automatic. We don't need a ton of brain power for that. In my experience, what we have to be careful with is the starting point, and then everything kind of falls out from there. So normally, the cosine function starts at a maximum. This time we have a phase shift of left 90 degrees. So we would normally go left 90, and we would start with the maximum here. But because our A value is negative, we have to start on the downside. We're going to start with a local minimum here, left 90 degrees. That will be our starting point. Okay, and everything unlocks from there. Our period is 180, so we'll have one full cycle every 180 degrees, or 6 squares on my grid, like so. If this is a all these are minimums, halfway between our minimums, we'll have maximums. So up here and up here and up here. And I even might go 3 over, a maximum here and a maximum here. And even if you just drew a curved line through those max and mins, that would be a great sketch of this periodic function. But we can add a little bit more detail. We know that halfway between a max and a min, so halfway between 3 squares is like 1.5 squares there. We're going to come back and touch the axis. This is a lot of detail. It's a really nice sketch of this periodic function. All right, as a 43-year-old man, my fine motor skills are lacking, so I'll do my best to make a nice curve here. That's not so bad, actually. But yeah, a lot of detail, and I really believe this algorithm, everybody can use it. The first part of this algorithm, just writing down our properties, setting up a sketch, everybody can do. And with a little bit of thought, we can figure out the correct starting point. And then using our period, we can figure out what the rest of the graph looks like. So that was 4 sine functions and 3 cosine functions. You really, at this point, just to kind of to get better at this, you just need to practice some more. So hopefully you check out the people in my class, check out the practice sheet, and do as much as you can and check your answers. And yeah, hope you guys are doing well. Take care. We'll see you soon.